Hello everyone, I'm Dr. Anand Kumar Gupta and I welcome you to my channel Bit Byte Learn. Today we are going to learn about OSPF. The OSPF stands for Open Shortest Path First. Before we're going to learn about OSPF in details, let's have a quick discussion about what is routing. So routing is basically a process of selecting the best path for a destination network from the source network. Routers, they maintain routing table which contains network path and next hop information. As you can see in this diagram, there is router 1 and router 2. They have been directly connected with the link of wide area network. The router 1 consists the routing table 1 which propagates the directly connected network, as well as the router 2 has its own routing table which propagates its directly connected network. So these two routers are maintaining their own routing table, and when these two routers are going to communicate together, they will exchange the routing table so that each router knows that the neighboring router can connect which network. So routing are basically of two types. It can be static or dynamic. Static routing is configured statically by administrators, whereas the dynamic routing protocol is being configured using routing protocol. So the OSPF is one of the dynamic routing protocol. It is a protocol which allows inter-domain routing. It manages routing within an autonomous system. The open shortest path first is a link state routing protocol, and the OSPF builds a complete map of network using link state advertisements. We will see how the link state advertisement works in details. So why OSPF is used? OSPF is basically fast, scalable, and efficient. It supports large enterprise network. It is fast in convergence, meaning network changes are detected quickly, supports hierarchical network design using areas, and supports load balancing. It also supports variable length subnet mask and classless interdomain routing. There are authentication options available for security purposes as well. How OSPF works? OSPF works using link state information received by neighboring router. Each router creates a map of the entire network topology. Instead of sharing the full routing table, router basically says the link state information whenever there is a change in the link. And this information is stored in the link state database. Each router uses the shortest path algorithm to calculate the shortest path. There are some of the terminologies in OSPF. You will find router ID. It's a unique identifier for each router in OSPF network. It is usually an IP address format value. Never is a type of another type of OSPF router directly connected and exchanging OSPF messages. Adjacency is a fully formed neighbor relationship between two routers and exchanging database information so that process is known as urgency. Then we have the links, like in this image, you can see the router ID. Router 1 has the router ID 1.1.1.1. Router 2 has router ID 2.2.2.2. And they have a relationship established, which is shown as an urgency, where the database exchange has been successfully completed and the synchronization has been done in LSDB. So how they form the relationship using Hello Packet Exchange. We will have a brief discussion on the type of OSPF packets in the following slides. Now we'll move to the next terminology, which is link state advertisement. So link state advertisement is a message used by OSPF to share information about the connected networks, the link state to neighbor router. And link state database, in short LSDB, is a collection of all the link state advertisements received from the neighbors. So LSDB represents the complete network topology. As you can see in this diagram, router A having the routing table network A is reachable through router A, network B is reachable through router B, network C is reachable to router C, network D is also reachable through the router C. So in that case, this information which is stored in the router A database is considered as link state database. Each router are going to exchange this database following the process of link state advertisement. So sharing the link state database information with the neighbor router is considered as the LSA exchange. Now we will move to the next section where we will see that what are the different type of OSPF packets. So OSPF supports 5 different packets. The first packet is hello packet, which is used to send by one router to discover neighboring routers. The next packet is database description packet, which is used to summarize database. Link state request packet is on other side is used to request missing information. The link state update packet sends full link state information to neighboring routers, and the link state acknowledgement confirms the recipient of the updates by the neighboring router. So these are the 5 packets, and you can see in this diagram, this is how the process flows. So it starts from the network hello packet, OSPF hello packet. Router 1 sends the hello packet to the network, and the neighboring routers respond, and following that process, the router is able to discover the neighbor. Then they share their database information in the form of the link state database exchange. Then they also send the packet if the link state information is missing. They send the update using link state advertisement and acknowledge once the update has been received. So these are the 5 different packets in action. The OSPF divides large network into areas. Why they divide into areas? Just to improve the scalability and reduce routing overhead on the routers. Always consider area 0 is a backbone, where the backbone is the area which connects all other areas in OSPF network. All other areas must be connected to backbone area. In this diagram, you can see there are 3 areas, area 1, area 2, which are connected to backbone area, area 0. And that allows the OSPF area connection. Moving forward, we have the OSPF matrix, how OSPF determines best path. So it uses cost as a metric. Cost is nothing but the bandwidth of the network. The lower cost mean better path. The routers play a vital role in OSPF, and they have different different roles to perform. Like internal routers belonging to single area are called as internal router. Backbone routers are used to connect area 0. Area border router then connects to multiple other areas. An autonomous system boundary router connects external networks. So like in this example, you can see the router R2 and R3 in this network are creating area 1. The R1 and the other routers in this area 0, area 2 having R4 and R5. So the router 2 is playing role of the area border router, which is connecting area 0 and area 1 and area 0 together. Then if you focus, you can see there is a router. The ASBR is performing the autonomous system boundary router, which is connecting the OSPF network to external network. If you focus, you can see there is a EIGRP protocol being configured on this area 3. So it allows to connect multiple external networks. Internal network, this for this area 0, R1 would become the internal router and the backbone router. And this is how the router's role has been defined. Moving forward, we have the advantages of open shortest path first protocol. It is fast in convergence. It allows efficient bandwidth utilization, supports large network compared to RIP. It is very robust and supports authentication mechanism as well. And it is a vendor neutral protocol. Vendor neutral protocol means any routers supporting OSPF made by any organization is supported. Moving to the disadvantages, it's a bit complex in terms of configuration. It have higher CPU and memory utilization and requires proper network designing. The a small difference has been observed between the OSPF and distance vector protocol. OSPF is going to use state algorithm where the distance vector protocols share routing table periodically. OSPF converges faster and distance vector protocols are simpler but slower. What are the real world use cases? It is ideal for enterprise network, good for ISP's internal routing, data center networking, and the large campus network. In the following video, we will learn how to implement OSPF in a lab environment, and we'll see how to configure it step by step. So see you in the next video. Till then, thank you and best wishes for learning.